Objective 1, what is weathering? Well, I'll give you the textbook definition in just a minute. You can copy that from a slide about the physical and chemical processes that change the characteristics of these rocks in their environment. But the definition I like is weathering is the breaking down of Earth's materials. So if you look at this cliff, these layers of limestone, they were all one, here one big thick layer, and the pieces break off from that layer. That is called weathering. Weathering occurs as rocks are exposed to their environment. And there are a number of different factors in the environment that can cause weathering. They influence the weather. So for example, here is the water, right? Over time, the waves coming up here and crashing in, right? The air and the wind might help it. Gravity helping to pull these rocks down. All these things are factors that influence how easily the rocks break down. How long have they been exposed? Because this layer back, if I go back there a little bit, I'm going to meet the cliff. Those rocks are not exposed to the surface like these right out here are. So there's many factors that influence the rate of weather. So if I'm looking for rocks that have been weathered, we got to find rocks that are exposed to the air and the water. Remember what two spheres those are? The air and the water. That's the atmosphere and the hydrosphere. Good job. So how do you know? What's the evidence that these rocks have been weathered? Well, you find smaller pieces, which we call sediments, that came from those that broke off. Sediments can be all different sizes. They can be the boulder that I'm sitting on right here. They can be larger, like a cobble. They can be smaller, sand, silt, clay. On your reference table, page 6, there will be all different sizes of sediments, and we'll learn how to read that chart. So now I'm at the ledge of the quarry, showing how physical weathering can happen either from human impact, like using a rock hammer to break up a piece, right? Or maybe if I wasn't here, in nature, naturally, something could happen and a piece falls off, and as that piece falls off, gravity pulls it down and it smashes into smaller pieces. Doesn't change them chemically, just smaller pieces in the bottom of the cliff. A rock quarry is a great place to show physical weathering. So here you can see all of the limestone that has been smashed using machines and jackhammers into smaller pieces, right? Physically weathered because it is broken down into smaller pieces without being changed chemically. Another example of physical weathering is frost action. Right? You can tell by the cracks and the potholes in this road right here. Winter time, you get a crack, the snow and the ice on the road, it melts, the water gets down in the cracks. It gets cold at nighttime, it freezes. Remember what happens to water when it freezes? It expands. So then it expands in this crack a little bit, makes it a little bit bigger. Next day the sun comes out. It's cold, but still the sun is shining on it, enough to melt that ice in the crack. More water goes deeper into the crack. Next night it gets colder, freezes again, expands, right? Makes it a little bit bigger. And over day after day after day of thawing and then refreezing, thawing and then refreezing and expanding, it makes these cracks larger until you get a good sized pothole that has to be fixed. Right? Physical weathering, it's the same road, it's just broken into smaller pieces. It's not changed chemically. Check out this short video clip as another example of physical weathering. This one is a natural water slide. And as you look at the video, check out the rock layers so you should be able to figure out what type of rock they are. And then as my daughters slide through, pay close attention to the edges of the rock where the water has been hitting up against the rock layers. See how smooth they are. The water from friction and abrasion, materials that the water is carrying, this brook of pebbles, sand, are constantly smashing into the edges of the layers of the rock and breaking them off. So by abrasion, physical weathering, they smooth off the edges. So hopefully you like this little video clip. I know my daughters have fun whenever we go there.
Okay.
Chemical weathering is the second type of weathering. It's where the earth materials, the rocks and minerals, are broken down, but then they change into a brand new substance, a brand new chemical. They are changing chemically. Perfect example of chemical weathering, right here on the side of my truck. We call it rusting. Rusting is an example of oxidation. Oxidation also happens with rocks and minerals, where you can see rust, where you can see oxygen from the air reacting with the minerals in the rock, or in this case the metal in the truck. The oxygen from the air reacts with them and it forms a brand new substance, which we call rust. Two other examples of chemical weathering are carbonation and hydration. I'm going to show you pictures in just a second of rocks that have been oxidized, rocks that have gone through carbonation, where carbonic acid from water and carbon dioxide reacts with the rocks, forms caves. It's very common with limestone. And then I'll show you a photo of hydration, where water reacts with minerals to get them all crumbly so that they break down into a new substance. So oxidation, carbonation, hydration, all types of chemical weathering. Chemical weathering dominates in climates that are warm and moist or humid. Perfect example, right back to the truck, right? The rusting of the truck. You need warm temperatures for chemical reactions to go faster. So hot, humid climates. Water, humid, is going to make it rust faster. Perfect example with my truck. How about in the wintertime? Where will my truck rust faster? If I park it in a warm garage every night, or I leave it out in the cold driveway? Think about what temperatures you need. It will rust faster in the garage because now the snow starts to melt, you get the water in there, and that rusting can happen faster. So why do I park my truck in the garage in the wintertime? Because I don't want to have to brush off the snow and the ice and scrape it. So out of laziness, I'll put it in the garage, but really the rusting is going to go a lot faster because it is in that warm garage every night. Weathering rates. How do you determine if earth materials, like rocks, minerals, are going to break down faster or slower? Different rates. Well, one factor is size. Let's take limestone as an example. Here I have about the same quantity of limestone. Here it's one large piece of limestone. Here it's spread out into a pile of smaller pieces. So different size. Large size, smaller sizes. Take a guess. Which one do you think will break down faster? And when I say break down faster, I mean break down into like this. Like clay, really small, fine dust. Which one of these is going to break down into that dust faster? The larger piece or the smaller piece? Well, if you guessed the smaller pieces, all of these smaller pieces will break down faster than that into the dust, you're correct. Now why? Why do the smaller pieces break down faster? It has to do with surface area. Smaller pieces are going to have more surface area. Smaller pieces, more surface area. Smaller pieces break down faster. What kind of relationship is that? Good. That's an inverse relationship. If you're struggling with figuring out how these smaller pieces can have more surfaces, let me give you an analogy. Imagine you had to paint the rock. So you had to cover all of the surfaces of this limestone rock. So you had your paintbrush, and you could go ahead and you could paint the whole top and the sides. You could pick it up and get the bottom, cover the whole surfaces of that rock. It might take you a little while, but you could do it. All of these rocks, you could pick up a piece, you could paint every single side, every edge, set it down, grab another one, paint all of the edges, set it down, grab another one. Right? Which one do you think is going to take you longer? Obviously, the smaller pieces. There's so much more surfaces there, so much more surface area for the hydrosphere in the atmosphere, remember the water in the air, to get at, to break down those rocks into a dust. If you're struggling with particle size, let me give you two analogies. You want to make some kind of sugary drink. Lemonade, Kool-Aid, iced tea. So you got to take sugar and you got to break it down into water. So do you want to use smaller pieces of sugar, or do you want to add a large piece of sugar? Which one is going to break down faster? Which one's going to allow you to do the less stirring? It's going to make your drink faster. If you've ever made iced tea or lemonade or Kool-Aid, you know smaller pieces will certainly break down faster. Anybody that's a coffee drinker knows coffee grounds make coffee faster than coffee beans. Why? What did we just say about the rocks? Oh, that's right. Smaller pieces, greater surface area. Smaller pieces break down faster. Give you one last analogy to finish up this section. You want to start a fire. You're going to start a fire with one big block of wood. Will that go very quickly? Or about the same quantity of wood, they're just in smaller pieces. Call it kindling wood if you've ever tried to start a fire. Which one is going to start the fire faster? If you've ever done it before, you know kindling, smaller pieces, get the reaction going faster. So I'm back in my garage with one last video clip on another factor that influences weathering rates besides size. See if you can figure out what this one is. Take different earth materials. So here I've got a piece of quartz. And you remember studying quartz when we studied rocks and minerals. Here is a piece of talc. Right? They're about the same size. Actually, the quartz is smaller. And to even show you that size is not a factor, I could take this piece of quartz, which is a lot tinier. So this is smaller. I'm not focusing on size right now. All right. What I want to do is I want to compare something else that's different about talc versus quartz. Remember anything about minerals? What's different about them? If you guess this, the quartz I cannot scratch with my fingernail. The talc I can. It comes right off of my fingernail. Right? What's different about them? Their hardness. Right? Quartz is harder, talc is softer. So now, think about that. I'm going to leave these two. Even this piece is smaller. Now we talked about how size influences it. I'm going to put these outside and leave them for 5 years. Come back in 5 years, one of these will be broken down, the other one will not. Right? After snow and ice and wind and rain, the sun beating on them, maybe somebody hitting them with a shovel, human interaction. Right? The quartz will not. Why? It's harder. Harder things will break down slower. The talc will break down faster because it's softer. Okay? So the hardness is a factor because the hardness is determined by the chemical composition and the structure and how those atoms are exposed to the weathering agents. The water, the wind, right? The weathering agents that will break it down. And then think about the relationship. What are we saying? The harder it is, like quartz, how will it break down? Slower. What would you do with your thumb? What kind of relationship? Fill in the graph.